Hello, welcome to the 4-6 notes on using congruent triangles. So today's objectives are to prove parts of congruent triangles are congruent. So the first thing you need to know is what is CPCTC? Well, it stands for corresponding parts of congruent triangles are congruent. I'm going to go ahead and write that in, so you may want to, after you see it pop up on screen, you may want to pause your video and quickly jot it down. Okay, so here it is. It's corresponding parts of congruent triangles are congruent. So C, P, C, T, C. And what does that mean? Well, up till now we have various ways to prove triangles congruent. They are side, side, side. Then we learned side, angle, side, hypotenuse, leg, but only for right triangles. Then angle, side, angle, and angle, angle, side. These are the 5 ways to show that two different triangles are congruent to each other. But if you use one of these ways, say we take side, 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 okay? If we use that way, we only know then that the 3 sides are congruent to the 3 sides of the other triangle. Well, CPCTC tells us that once you know that the triangles are congruent, all their corresponding parts are congruent. So to prove, you're usually going to have 3 things that you know for sure are congruent in 2 different triangles. Then once you know that they are congruent, CPCTC says, oh, all their parts are congruent because we know that the triangles are. Okay? So example 1 over here, it says, which triangles would you need to prove congruent in order to prove the following congruence? Well, we have a side and a side, so that's 2 sides. Looking over to this list, the only ways to prove congruent with 2 sides is either side, 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 or side, angle, side. So you would have to ask yourself, okay, what can I show here is congruent? Can I prove the 3rd side to the 3rd side, or can I prove that included, the angle in the middle? The included angle would be this one and this one. Can I prove those congruent? Not really. There's no evidence here that shows that those angles are congruent, so it has to be side, side, side. Also, like I have told you in the past, when you have these 2 triangles that are back to back, flat up against each other, that side by reflexive property is always congruent to itself. So I would say I would have to prove triangle ABC. The way I write the first one makes absolutely no difference. I write it however I want, but then I have to follow that same pattern for the second one. So I went from A to B to C. So I went single tick down the middle. Do the same thing here, single tick down the middle. So it'd be triangle DBC. All right, last 2 examples here, same thing. Which triangles would need to be proven congruent in order to show that BC is congruent to AD for this one? So automatically, like I said, back to back, I know that that side is congruent to itself. Can I prove these triangles congruent? I have a side, angle, side. So by side, angle, side, these 2 triangles would be congruent. So I would say triangle BAC. First one I could write however I want. The order does not matter, but the second one is very important that I follow that same order, the corresponding order. So then I would say triangle DCA. All right, this last one here, BD congruent to BE. I want to be able to show that those sides are congruent. So I notice that I have an angle and I have a side. So I would have to decide what can I prove here? Can I prove angles or can I prove another side? If I wanted to prove another side, it would have to be this one so that I could have a side, angle, side. There's nothing here that tells me BA is congruent to BC. I would not be able to argue that at all. So that way it's not going to work. The only other thing is angle, side, angle, or angle, angle, side. So because these angles here are congruent, I would be able to say, okay, well then this one is congruent to that one because they're supplementary to the same angle. So that would be an angle, side, angle. The triangles that I could prove congruent would be triangle BAE, BAE, congruent to triangle. If I went from B to A to E, I would have to go from B to C to D. Now again, I told you we're not doing proofs that much this, or at all really, this chapter like we used to. This did apply a lot more when doing proofs and trying to prove certain parts of triangles are congruent. right now doesn't apply that much, which is, that's okay. But just know that if you know triangles are congruent, then you could say, okay, every single thing. So like now, if I prove that these triangles are congruent by angle side angle, I would say, okay, BA is congruent to BC. Why? CP, CTC. Corresponding parts of congruent triangles are congruent. All right, that is it for today. Thank you for watching. Have a good one. Bye.